So next problem is a problem with UDL and UVL combined. Find the deflection and slope at the nodes for the beam as shown in the figure. This is a figure. Take E is 70 GPa, I is 2 into 10 raised to minus 6 meter to the power of 4. So we have two loads. One is UDL and another one is UVL. So I have written the FE model. This is common. I have already told you in the previous videos also, and I have written the K values. We have already seen how to write a K value in the previous video. If you are not getting how to write, just check the previous videos. Here L value is not 1, it is 2. That's why if it is 6L, 6 into 2, 12, and 4L square, 4 into 2 square, 4 4s are 16, and 2LE square, that is 2 into 2 square, that is 2 into 4, 8. So like that you will get K1 and K2 is same. Since both elements have the same length, you will get the same value. EI by LE is same for both the element. So I will get 17.5 at that point. And this is the total matrix I have written. By combining both the matrix, we will get it separately, like K1 and K2 separately, and I have added it. For adding, you can refer the previous videos. After finding the K matrix, what you have to find is the force vector. We have two force vectors. One is UDL, another one is UVL. So UDL, we have the formulas like this or equations like this, and W value is 1 kilonewton and L value is 2, and we find the answers for that here. Since the direction is in the opposite direction, we will take W value as minus 1000 Newton per meter. So that's why this is negative, and negative into negative, it is positive here. Next one is force vector for element 2, that is UVL. We have the equations like this. We have another equation which is added to this, WL by 60, like that. Since the end here is 0, this is ending to 0. As you can see in the previous videos, we are not ending it 0 in the previous video or previous problem, but in this we are ending it to 0. So that's why we have neglected that part. Only the first part we have taken. And W value is minus 1.5 into 10 raised to 3 Newton per meter, and 21, 3L, 9, minus 12. So if you multiply this, we will get these values. After this, we have to write the position value and add the force vectors. So that is F is equal to, we will get 6 into 1 matrix, that is 1, 2, 3, 4, 5, 6. And this is for the first part, 1, 2, 3, 4, and this is for the second part, that is this is a transpose, that is 3, 4, 5, 6. So first element is 1, 2, 3, 4. Second element is 3, 4, 5, 6. That's why I have written it as 1, 2, 3, 4 and 3, 4, 5, 6. This transpose, this has to be written it like this itself. So don't get confused. I have written transpose for that. Here it is not written. And I will add the common terms. Rest of the things have to be written. First one, 1 will be only this minus 1000. 1 2 will be minus 333.33, and 1 3 will be minus 1000 plus minus 1050, that will be minus 2050, and 3 4 that is 1 4, that is 333 minus 300, that will be plus 33.33, and 5 we have minus 450, and 6 we have plus 200. So this is the force term which we have got it. And the next part is finding the displacements. So I have written the equilibrium equation. We can see equilibrium equation, and we have to find the boundary condition before solving the problem. So here you can see that this Q1 and Q2 is fixed, Q5 and Q6 is fixed. Only this term has to be found out, that is Q3 and Q4, as well as so as you can see, this is also fixed, this is also fixed. So Q1, Q2 and Q5, Q6 is 0. Q1 equal to Q2 equal to Q5 equal to Q6. So we have to cancel off first row, first column, second row, second column, and fifth row, fifth column, and sixth row, sixth column. Now remaining things are what is remaining, we have to write it down. So 3, 240032 Q3 Q4 equal to these two remaining minus 2050 and 33.33. So from the calculator we can find, from the calculator it is given as Q3 equal to minus 4.88 into 10 raised to minus 3 meters and Q4 is 5.95 into 10 raised to minus 5 radians. So these are the two values and deflections. This is the end of the problem.